This is the first topic in Unit 6, and Unit 6 is our final unit of Algebra 1, and it is the unit on data. So what we're going to be looking at today are different ways to display data, and because it's math, we're going to be looking at different types of graphs. So graphical displays of data. So this is a PowerPoint because of the graphs. So I want to mention that you don't necessarily need to write down every single thing that you see. You need to make sure that you are covering the information and getting what you need out of this PowerPoint. All right, so first up, box plot. So back in the olden days, this was called a box and whisker plot, and it's very helpful because it shows 5 basic pieces of information. It shows you the lowest value and the highest value, and then it shows you that box in the middle shows the median as well as the lower quartile and the upper quartile. So basically what's happening is that box is showing you where half of the data falls. So if I was a teacher, this would be helpful information because I would know that within that box is where half of my students are performing. Pros and cons. So advantages, you can see the 5 points pretty clearly. You can tell the highest and lowest, so that gives you an idea if there are outliers on there. It's definitely easy to compare two box plots. If you have a lot of information, so a lot of data that you're trying to put into a graph, this one's pretty good because it really only has 5 values. So when you look at it, you don't know whether there's 5 values or 500 values in the box plot. Some disadvantages, it might not be as easy to read, especially if you've never seen one before. You may not realize that the box is showing 50% of the data. And the exact values, the only exact values you have are the minimum and maximum. Keep in mind that the median and the lower quartile and upper quartile do not necessarily have to be data points in the set. Next up is a dot plot. This is also called a line plot. This one is a frequency graph. What that means is that it's showing you how many times a response occurred. So all of these dots would be representing a response to whatever data information you're looking for. So you can see on this graph that 2 of the responses were 1, 3 of the responses were 1.5. There was 1 response of 2, 2 responses gave 2.5, and so on. So it's a frequency graph. So that tells us how many times. All right, pros and cons for this one. Simple to make and shows each individual point. Disadvantages would be going along the same lines. If you were making a dot plot for maybe grades in, let's just say, Math 8, that would be almost 150 students that would be on your dot plot, and every single one of those would be represented with a dot. So it can be time consuming when you have a lot of information that you're trying to display. Another problem would be if you were using whole numbers, no big deal, but if your data included information of fractions and decimals, that wouldn't be very easy to display on the dot plot. The next one is a histogram. So a histogram is basically a bar graph. There's a few differences. This again is a frequency graph. It's showing how many in a range of numbers. So what that means is it's not necessarily showing you how many people made 100, how many people made 99, 98, 97. It's showing you all of the people or how many people scored in the 90s. So there's no way to actually tell what the values are because they're in a range of values. In addition, the bars on a histogram touch. A traditional bar graph, the bars are not touching, but in a histogram they do. So again, a histogram is going to show the frequency, which is how often or how many times a response occurs, but on a histogram, it is in a range. So advantages: visually strong. People have no trouble reading bar graphs. They're very easy to read. And it's definitely good for determining the shape of the data, which is something that we're going to be talking about in the next few days. Disadvantages is that you cannot read the exact values at all. So when you see the bar on a histogram, it's showing you all of the scores that occurred between 80 and 89, let's say. So there's no way to tell if all of them were 80, were they distributed evenly, were all of them 85s? There's no way to tell exact values. It's also more difficult to compare two data sets with a histogram, particularly if the ranges on the bars are not the same. All right, moving on to the statistical information. So the mean is the average, and I'm pretty sure you guys know how to take an average. You might not know that this symbol, the X with the bar over it, is a symbol to represent the mean. The median. The median is the middle value of a data set. So if there's an odd number of numbers, it's the one in the middle. If there's an even number of numbers in your data set, then it's going to be the average of the middle two. The median splits your information into 50% high and 50% low. The first quartile is the median of the bottom half. So we take the median, which splits our data into two pieces, and then we take the middle of the bottom, and that's known as the first quartile, or you can also call it Q1. The third quartile is going to be the middle of the top half. So you find the median of the data, that splits your data into two halves, and then you're going to find the median of the top, and that's the third quartile. So again, the median is the number in the middle. They do have to be in order. You can see since our original our original set had 10 values in it, our median is in the middle of the fifth and sixth. But when we do the upper and lower quartiles, those are now set of odd numbers. So the middle number is our first quartile and third quartile. The interquartile range is the difference between the first and third quartiles. So basically what you're doing is you're finding the middle 50% of the data. So the median splits the data in half. When you do the first quartile and then the third quartile, you end up with 4 groups. Each of those represent 25% of the data. So the interquartile range is going to be that middle 50%. An outlier. So in the past, you may have just been told that an outlier is a value that's much greater or much smaller than the rest of the data, but it is actually calculated algebraically. Now, I don't know who decided, but whoever decided that it was going to be 150% of the interquartile range from the first and third quartile. So what that means is that you're going to take the interquartile range, multiply it by 1.5, add it onto Q3, and subtract it from Q1. And I have an example showing this at the end of the PowerPoint. All right, so here we go, interquartile range. So the numbers below represent how many home runs were hit by players of the Hillgrove baseball team. So as you can see, these are already placed in order. So first thing we're going to do is find the median. So keep in mind that the median isn't just size-wise. So if you look at this, you might think that 14 is in the middle because it's kind of balanced in the middle. But if you actually count the numbers, then you'll see that the median is at 12. That separates the data set, which had 12 values, into two groups of 6. Then we go through and find the lower quartile, or Q1, and the upper quartile, or Q3. And that is just by finding the median of the bottom half and the median of the top half. So the first quartile is 6. The third quartile is 20. So the interquartile range would be 14. So the middle 50% of the information falls between 6 and 20. All right, for this one, I'm going to exit out of this so that I can show you on this. And let me bring this back in here so I can set this up. All right, so we found the information on our last slide. So we know the median is located at 12. So I have this line right here to show the 12. The lower quartile was 6. The upper quartile is 20. So you can see right back here, this box represents the middle 50% of the information. The lowest score, or the minimum, was 2, and the high score, or the maximum, was 28. So that represents our box plot. All right, so now we're going to look at outliers. So the way we find outliers is we take the interquartile range, which is 14, and we need to multiply that by 1.5. The easiest way to do that is to take half of 14 and add it back. So if we want 1.5 of 14, then we're going to take 14 plus 7, which gives us 21. Now 21 is going to be added to the top. Whoops, hold on a second, grab the wrong box, hold on. All right, I'm going to add the 21 to Q3, and then I'm going to subtract 21 from Q1. All right, so just to redo that again, let me back that up. All right, so we took the interquartile range, which is 14. 1.5 of that is 21, because half of 14 is 7. 7 added back, that gives us 1.5. So 21 is the magic number. So now what I'm going to do is I'm going to add 21 onto this end, which brings this down to 41. And I'm going to subtract 21 from this end, which brings it down to negative 15. So that is how I'm going to identify if there are any outliers. If I have outliers in this information, then that's going to be larger than 41 and smaller than negative 15. So right here, the boundaries for the outliers are negative 15 and 41, and there are no outliers in this data set. All right, we'll work again more with creating each of these graphs, and as well as more practice with finding any outliers.